Hello, I am Shane Brinkman-Davis. I'm a developer with GenUI, and I'm back. It's been a little while since I've done one of these, trying to get back in the swing of things. So a lot has happened since the last few live codes I've done. The holidays happened, I moved to a new house, and I released hooks-for-redux. So I did several live codes about sort of leading up to this about, gee, I wonder if I can make Redux better. Gee, I wonder how I could do Redux better. Redux seems really redundant. It seems like a good idea, but it's poorly designed. I did all these things, and then I sort of dove in and I did it. Hooks-for-redux. And maybe I will just start with doing a little bit of a code review with you on this. But first, I want to give a little bit of context about the reception I received after releasing this. So I released it, and I announced it in a few places. Hacker News and Reddit. Reddit seemed to be the best place to announce it, and I made a Medium post. I had reached out to a few Medium people who were writing similar articles, and one of them said, "Oh, well, I'll link to you or repost it or whatever if you write an article on this." And it's like, great, I'll write an article on this, which was great because I wrote this nice article on Medium, which I will link to in the show notes, which sort of explains it all and goes into it. And it prompted me to make this cool little logo that you can see there. But the strange response that I got, I certainly got a few people who were interested, but I got this person from the Redux team responding and said, hey, well, the new official way of doing Redux is Redux Toolkit. And I was like, oh, I didn't even know about Redux Toolkit. I tried to Google this every which way I could, try to find other projects that were doing similar things. I didn't find anything, but I think it's because it's hard to find. Since releasing it, I learned about Redux Toolkit, which is the Redux official answer. And there's also Easy Peasy. That's what it's called, Easy Peasy, which is also a way to streamline Redux. Of the two, Easy Peasy is way better, and of the three, hooks-for-redux is still the best. But anyways, I kind of got into it a little bit with this guy from person, I don't know if it's gender, from the Redux Toolkit team. And they basically encouraged me to try out Redux Toolkit. And they have an easy, medium, and hard level of Redux Toolkit. So the basic tutorial really is quite basic, so I will just not even look at that. But the intermediate tutorial was worth looking at, and then the advanced tutorial. And basically, Redux Toolkit does try to streamline Redux a little bit, but it largely fails. It gets a little bit of few things right, but it largely fails. And I am writing an article on that, so I'm not going to go into too much detail here, but here's the problem with Redux Toolkit. It still tries to expose all of the inner workings of Redux all over your React app. So you're still doing dispatching, you're still doing action creators, you're still doing all that kind of clunky stuff to get anything done. There's no need for that. There's the dispatch aspect of Redux it's good from the point of view of you can record a set of dispatches and you can play them back and you can see them in a log so you can debug. But it's not good from a programming point of view. The problem is that Redux is essentially a global store, and as a global store, it has all the same problems as a global variable does, which is that your entire application can access it, and so your interdependency between all the different parts of your application kind of explodes. And so much so that you can accidentally mess up code in other parts of the application because of the nature of globals. We don't do globals because globals are bad, and Redux is a global store. That can be avoided with what is called Modular Design, which is the other article I'm working on. So I came to this realization. So I went through and I did the intermediate tutorial with hooks-for-redux, and hooks-for-redux just blew it away. Half the code, half the file. And I went through and did the advanced tutorial. And so you might notice I'm actually searching for H4R Redux. Hooks-for-redux was maybe not the best name. I do want to say I'm like using React style hooks, and I'm applying it to the way you write Redux. But hooks-for-redux, Google still doesn't mark me very well. But so I started using this acronym H4R, and as long as you do H4R and Redux, everything is just relevant to this. But at the end here, I have prior work, and I've got a link to a lot of different things here, including hooks-for-redux versus Redux Toolkit. Yeah, so the intermediate, it was 58% less code. And I didn't even go into the files here, but I've got all linked to off of the GitHub page. You can compare the two versions, and there's a lot less code. So there still is a ton of code with Redux Toolkit. And the problem, so I kind of got in with this guy there, and I got in with him on another post on Reddit on Redux Thunks. Actually, the original post was on something that was an alternative to Redux, but somehow got off into Thunks. So Redux Thunks. What is a thunk? A thunk is just a function that returns a function. That's all a thunk is. Okay, fine, we have a name for it. It's, as best as I can tell, it's completely make work for Redux. I ended up talking to this guy, same person, and talking to them about like why do you need to use thunks for Redux? How thunks are used is you dispatch a function that returns a function. To me, that's already messing up your dispatch. The whole point of dispatch, the reason why the dispatch mechanism is even worth doing, is so that you can log it and restore it and play it back. And that only works if it's plain, if it's just plain JavaScript objects. If you're dispatching a function, you can't record it and play it back. You can't persist and then restore a function because it won't restore the closure. But the whole reason for thunks seems to be asynchronous loading. And I sort of said, look, well, that's fine, but you can do asynchronous loading just with a plain function. You just make a function call, it does some asynchronous work, and then when it's done, it dispatches updates to the Redux store. And for whatever reason, we kind of missed each other. Maybe I missed something. I'm always willing to admit that I missed something. I am always learning. But as far as I can tell, it makes it way more complicated than it needs to be. You should not be dispatching functions through Redux. And there's no need for it. If you write just a simple function which does your asynchronous request, and then you dispatch the update to Redux, it makes the whole thing much more replayable and debuggable and repeatable and clearer, and you don't need thunks at all. So anyways, I got into that. I kind of feel like the official use of Redux is a little bit overly enamored with the dispatch system. The dispatch system is, like, here's one of the problems with the dispatch system. You are using a name, this action type, to link several things together. So you would create this sort of interdependency mess. And the name has to be correct in multiple places for it to go through the system correctly, because you have to dispatch the right name, and then you have to have the right reducer to detect it and then do the right reduction based upon it. It also means it's a global namespace for these actions. So if you have two actions that are called update info, then whereas you think I'm just going to dispatch an update info update, well, all of a sudden two different reducers get triggered that might have had nothing to do with each other because they have global namespace clash. So this dispatch system in Redux is really, actually, I would say its weakest point, not its strongest point. And that's part of what hooks-for-redux, what they end up doing with the Redux Toolkit, with their demos, is they, I don't know if I can zoom to it right away. We might get to it, but that's not really what I'll focus on today anyway. They do half the equation. They actually have a fairly nice little way of defining your Redux state. Works pretty well. So I give them kudos for that, but they don't do a very good job at simplifying your React usage of Redux. And that's where hooks-for-redux still does a great job. So let's take a look at what hooks-for-redux is doing. As I'm going through this, I'm going to be talking a bit about modular design. As I said, I've got two blog articles that are just about to come out the door, one on modular design and one on modular design applied to Redux. I ended up separating them out. And I begin to realize that the main problem with Redux is not the Redux itself. Redux, the library, is fine, works great. But the way it is advocated to be used is not just not modular, it is actively anti-modular. And modularity is the only way, not the only way, I don't want to ever put things in absolutes, but it is the most useful way, most effective way to scale large projects. Modular design is how you manage code as it gets bigger and bigger, as you go from a 1,000 line file to 10,000 to 100,000 to a million lines of code. It's modular. As I've said before on this live code, I manage 50 plus open source projects. No one's really using them except for me, but it's hundreds of thousands of lines of code. The way I can manage it is because of strong modular design. And what modular design really comes down to is maximum encapsulation of a module, making it as leak-proof as possible from the abstraction point of view. Nothing's completely leakless, but all abstractions leak. But you can make it nearly watertight, which is to say that the exposed API precisely defines absolutely everything you need to know about interacting with the module. So the other half is making a well-defined, simple, clean, exposed API. Those two things together tend to lead to the third most important thing, which is reducing the interdependencies between modules overall. And that is where Redux Toolkit tends to fail. Where is it going to go? We're just going to go do stuff here. Is it screenshots? Well, yeah, I think this will work. So this screenshot, this is sort of a preview of the blog. So this is their intermediate tutorial. These are arrows showing the interdependencies that they have set up within all their files. Each one of these, the rectangles are files in the project. The oval, the capsule-shaped oval things are external dependencies on NPMs. And the solid lines are direct imports, so they're actual concrete import statements in code. And the dashed lines are what I'm calling indirect dependencies, which are effectively, from a complexity standpoint, just as significant as the direct imports. For example, filter link imports parts of filter slice, and then it immediately passes it to link. And then link uses those parts of filter slice directly, which is to say, if filter slice changes, you have to update both modules, because both modules are now dependent on filter slice, even though this one doesn't import it directly because it gets passed through from one module to the other. That's what I mean by indirect dependencies. Versus, this is modular design. Let's see if I can make them reasonably fit on the same screen together here. So we're going from 27 dependencies down to 13 dependencies. Further, hooks-for-redux takes these two parts and merges them together. So there's a little file called Modular Redux, which is not a lot of lines of code. But you take those two together and you only have one external dependency in your entire app for Redux, which is hooks-for-redux, which is why I have a little H4R here. This file, all of these files together are half the code of these files. And this example right here, you don't need hooks-for-redux. You could use hooks-for-redux, but this is actually pure JavaScript and just Redux. And it's half the code. And it's less than half the dependencies. In fact, it's closer to a third of the dependencies. That's huge. Absolutely huge. This system is completely unacceptable. It will not scale. You're going to kill yourself trying to get things done. You're going to kill your team's productivity. And my realization is because whoever's running Redux doesn't quite understand modular design, doesn't understand that you need to make all of these blue ones are React components. React should not have any direct dependencies on Redux. There's no reason to expose the dependencies on Redux in your React app. It means it limits your ability to refactor things. And in fact, in that sense, I experienced that with the advanced tutorial. Let's come back to that in a minute. Just to point out, this one also has the dependencies. There are no indirect dependencies. And that's not just because I'm pumping out my own solution. There really isn't. It's like you could, if I change filter, only these 3 files care, really, at all. App doesn't have any independency on filter at all. It doesn't matter. This to-do app, by the way, has a list of to-dos, and it has a filter which lets you choose if you want to show the all to-dos, the complete to-dos, or the non-complete to-dos. So it's just an example of having 2 different slices of Redux that you're using separately. But if you look at it, it makes perfectly good sense. All right, when you're showing a to-do, it might be filtered. Same with the filter list. In fact, actually, I squint my eyes just a little bit. Does to-do even really need to be on the filter? I could double check that. That seems almost like that shouldn't be necessary. There's the footer. The footer is actually the interface. It's not very clear. I'm not even sure I would call that footer, but I tried to refactor as little as possible, which has, it depends on filter because that is the interface by which you change your filter. And adding the to-do list depends on the list of to-dos in the state, and the adding a to-do has to do with the to-dos because that's what adds a to-do. So those dependencies make total sense. The app presents the to-do list and add to-do form. This is actually the form and a footer. It makes total sense, and your root file. Totally straightforward. One of the things is you'll notice that there's less React components in my version of exactly the same app as this app. Why is that? Is that even fair to compare these two when I reduced some of the Redux components? Because I removed filter link and link. Is that just unfair simplification? Well, I don't think it really is. And so here's why. Let's start looking at code. Hooks for Redux. There we go. Let's go into the modular Redux to do 2020. Actually, let's do RTK. I've got all the versions here. So I'm not going to do hit hooks or Redux for you right now. I'm just going to dive into this. So going back to our diagram here. So let's look at, first of all, I want to see really quick what to-do is doing. Let's take a look. Why is to-do dependent upon filter? It isn't dependent upon filter. It isn't at all. I need to update that diagram. File, open recent, modular Redux dependency diagrams. Over here, nope, over here. And we go down to the bottom. Not even necessary. 12. Mind-blowing. Oh, I see. So it's dependent on to-dos because it has a toggle to do. So, all right. Good to fix, but it's just that this is wrong. This should be here. No worries. I'll have to update my diagrams later. But so back what I'm going to do, we're looking at footer versus filter link and link. So here's what I want you to compare when you're thinking about this. The problem with breaking modularity is you're adding complexity to the system, and complexity begets complexity, which is to say that once you start having more and more complexity, in order to manage that complexity, you'll end up adding even more to the system to make it even more complex. And so it can be kind of a snowball. Like you can literally accrue more and more complexity because you have more and more complexity, like a snowball rolling down the hill and becoming a giant snowball, which doesn't happen. I've tried it. It turns into a wheel, not a giant snowball as in the cartoons. And then it falls over eventually. You get the idea. You should definitely try that. If you ever get a chance to roll a snowball down a really big snowy hill, it's kind of amusing. It really does turn into a fairly large disc and then it falls over on its side. All right, let's do RTK, convert to-dos. I want So this is their implementation. I'm going to close this out here because that's just hooks-for-redux source. So they have footer, and they have a filter link, and then it has a key which says what filter link it should be, what filter it should select. So that's okay. I'm not completely, it's not terrible, not great, but it's not terrible. I can go into filter link. So you notice it's a filter link. So it is a link that is tied exactly to the concept of picking which filter you're going to do. It's not a general purpose reusable module. There's nowhere else in the entire application you'll ever reuse this module. And then they have this whole file. This whole file is doing this connect map dispatch crud. That is the old school way. And in fact, the guy I interacted with did actually say, well, I could have used the new school. You could have used React hooks. The React hooks solution is a better way to do this, but this whole file exists because of the terrible way that React Redux handles this. Neither here nor there. It's because in the old school way of doing React Redux, they wanted it to be passed in as props. So there's like this sort of in-between component that gets Redux updates, converts it into props, passes it as props down to the child component. That was the wrong decision. When I wrote my art flux, because I was like, React people, their flux concept was okay, but it was pretty crappy. I had this decision, which, that's state, not props. So when I get an update from my global state, which is our flux, but it's like React, it should update a component's state, not its props. Mostly I wanted to keep props pure. I wanted to make it the props that get passed in from one component go directly to another component. There's nothing in between. There's nothing interpreting those props, making it confusing. But also, the workflow of building an app is you'll start building a component, and then you might need to add some state to it. And then you realize, oh my gosh, this state needs to be shared by other components. It's state. And instead of going through this cumbersome process of converting your state into props, it's much simpler to convert it from local state to global state, or to shared state, as I prefer to think about it. Because if you use Redux in the right way, it doesn't need to be treated in a global way and have most of the problems with global stuff. I'm sorry for the asides. I'm kind of ranting here. I've been thinking about this a lot. All right, so filter link. Oh, look, filter link actually doesn't really there's not even a component in here. There's just all this mass of trying to hook it into React. So this is entirely this is entirely Redux artifact. The entire thing is a Redux artifact, this entire file. So of course I eliminated it because it's completely unnecessary. And then it looks over the link. Well, here's the thing about link. All right, so you've got a link component. That sounds like a really good reusable component. Look what's getting passed into it. Active, children, set visibility filter. This is not a reusable link at all. This is tied specifically to filtering. And once again, will not be used anywhere else but in the header. So look at all that. And now go look at this implementation. This is all of that. All of those files simplified into one map. So here, as for here, we had this footer file, which incidentally, look, it's slightly longer. It goes from 14 lines of code to 17 lines of code. It's 3 more lines of code. And we completely eliminated filter link and link, which is together like 40 lines of code. The reason is because my implementation here is not in any way dependent on Redux. I mean, the word Redux shows here because that's just my pathing to my filter module. My filter module's API is a React hook, a plain function which is set filter, which you just pass in a filter name, and a list of all the filter types, which I can just iterate over. So I get that's that. Let's just go open it up over here. So if I go to the filter, here, this is the entire definition of the filter slice, incidentally. Here's all the filter types. It's just an object which maps names to functions which apply the filter. And so over here, in the header, footer, we're just iterating through the this list, which we all only care about is their names right now. And then it's just making a button out of each one, which is exactly the same core implementation once you get down to it of Link. Here, it's just a button. It's just this little chunk of code right here. So because I'm not putting any direct dependency in Redux, and these are just simple functions. This is just a simple map, simple object, plain object with functions that we're ignoring. We don't even care what those values are. A simple Redux hook, React hook, and then a simple set filter, which again only takes a string. It just takes a string, which is the name. It allows us to implement this whole thing super cleanly. And my point is that it reduces the complexity such that it became obvious that all that extra complexity was make work. It was stuff to cover up the fact that the system was overly complicated to start with, which it did not need to be. It's super important that you always minimize complexity to just the necessary amount for the project, which is what I call Zen, zero extra nuts. There's another popular acronym called YAGNI, which is terrible because it's called "Ya ain't gonna need it." And it's a terrible acronym to say YAGNI. Zen, zero extra nuts. You want to build to the spec and nothing more, because specs are always changing. And if you build more, it's going to be thrown out. You want to make it meet the spec, which is to say it needs to be correct, it needs to be performant, but it shouldn't be any more. So that was a long-winded way of talking about modular design. So again, this is all pure JavaScript, no external dependencies. It's all because of this one file right here, 37 lines of code, which is a slightly streamlined version, more or less, of hooks-for-redux. Hooks-for-redux has a little bit more functionality than I was using in this demo, in this conversion, but this is basically the way how hooks-for-redux works. And allows us to, this is basically all the code we have for a filter, and you saw the to-dos, which is, oh, that's the big thing, right? A list of to-dos. That's the source code for to-dos. That's everything. It has all the logic for adding a to-do, toggling a to-do, resetting the to-dos, which is actually only used for testing, but it is useful for testing in this case. The name of the Redux slice where this is being able to be stored, and a initial list, which is empty. If you compare that over to hooks-for-redux, their to-do slice, it's not a lot longer, but it is more clunky. It just is. Look, the action comes in mine. The action is already defined. We already know what the action is for the rooster, so you just have the current state and the payload. In this case, adding a to-do, you just add the text. Or the payload to toggle a to-do is the to-do's ID. But here, it's coming in as an ID and text. And here's another thing that I think is a rather broken design, is that they have this prepare statement, which is to say when you call add to do elsewhere. You don't even call it directly. You have to do an action creator and they have to dispatch it. And then it's generating the ID. And then that's running that through the dispatcher. So it's generating the ID first and then dispatching it. To my mind, that is fairly broken because it puts the logic in the wrong place for creating a unique ID. It makes it not replayable. So suppose I ran the application 2 times and I added a set of to-dos once and I recorded that, and then I added a set of to-dos again and recorded that. If I play those 2 back in sequence, you know what I'm going to get? I'm going to get clobbered to-do IDs. I'm going to get overlapping to-do IDs because the guarantee of uniqueness is not done in the reducer where I have the current state. It's done in this prepare statement, and then that would get persisted if you tried to persist the dispatch. So all this is way unnecessary complexity, and it's backwards. Toggle to do, but this seems all very similar, but it returns these actions rather than actual functions. Well, let's just go through and look real quick. So another thing is this organization is totally broken. So they've got a components folder, but most of the components are not in the components folder. And I could see some justification of putting your shared state in the same folder as other components that depend on that same shared state, see a little bit of distinction for that, but I've always found it more useful to separate out shared state into its own section. I think it's easier to think about because shared state is a cross-cut across the application. Even if it's not shared by all of these, I think it is much simpler to have, here's my components, I just have 4 of them, and here's my Redux state stuff. In fact, this one is actually hooks-for-redux. That shouldn't even be here. And this one's a test. So there's really only these 2 files. Anyway, let's go over here to the app. I just got to thread through app to do, visible to-do list, footer, add to do. So where the heck does add to do come from? Part of the problem with this is that these guys end up threading across to each other. I didn't even account for how much pathing you have to do to get between the different modules. Another aspect of modular design, I think, is you should think of a folder as a module as well. And so you should try to make a folder as leak-proof as possible. So the items inside a folder should not reference items. You should not reference, this should not reference in, I'm saying this all wrong. Think of it as a module, which means it should be encapsulated, which means that things outside of that directory should not reach inside that directory. It should just access the directory, but not things inside a directory. It should be well encapsulated. And then you also want to sort of minimize its external dependencies at the folder level. I'm not going to go into that too much here, but it does sort of guide your directory structures if you think about it in terms of how are these files going to cross-reference each other? How can you minimize it so that you're not reaching into other modules from one module to another? Like app here. App is in components. It's not showing you the .. but there's actually a effective .. They're using some builder here, which allows them to avoid that. But it's in components. They're going up one folder, and then they're reaching into features, which should be private, and extracting these various parts. All right, enough on that. I have been all over the place today, being kind of distracted, but this is kind of fun. So visible to-do list, add to-do is what I wanted to see. So here's add to-do. So here's what we're doing. They're grabbing add to-do from the to-do list. Oh my gosh, and they have this map dispatch thing here, which is I just don't, honestly, I don't even understand the complexity that this React Connect item is doing. It's just insane, honestly. It's a way excessive amount of complexity for no reason whatsoever. Look, ironically, they're even using hooks here, but for some reason, they bent over backwards not to use hooks here. That's forgivable. I don't know why they made this choice. He or she made this choice of using the old way of using React Redux. Their advanced tutorial uses the new way. The new way is using hooks, and that's what you should always use. This old way was terrible. My guess is that because it was a tutorial, they wanted to demo how you could use it with the old way, because people have existing apps that use the old way. Okay, I'll give it to that. But it's also a demo for new people learning how to use it, and there's demoing a terrible way to do it. So I think that's kind of a bad answer. Anyway, so here's our add to do. All right, so maybe I'm a little bit wrong on that. It's hard to sift through the complexity of these tutorials to understand what the heck they're trying to do. Look, so add to do does appear to be just taking the text. So maybe that part is okay. But it still comes through, as we've already seen, on the other hand, as a action, which is a payload and an ID, and that comes through here. It's just a huge amount of extra complexity compared to here, where add to do just is text, and all I'm doing is returning the new state, which is all the existing to-dos, and a new one, which is the text, not completed yet, and a new ID. They also make a big deal about how they're using this mutable state. They're using a library which lets you have state that pretends to be mutable, but in fact it is not immutable. It's doing like magic behind the scenes so that you can do something like push, but what you're really doing is you're actually causing the whole state to get reconstructed. I don't know why. I think maybe people thought that felt more comfortable to do it that way, but it's not any less code. And really when it comes down to it, code and complexity is what matters, not doing it the old way just because it felt good. As you can see, this is, well, that's it. That's the entirety of all of the code here for doing adding a to-do versus this add to-do is, all of this garbage. So the actions do actually dispatch, so I give them a little bit of extra credit there. But it's still just amazing how complex this ends up being for no good reason. This is just classic, classy, not great design. So part of my improvements were due to just making a better implementation. Generally speaking, you don't want to do switch statements. If you're doing a switch statement, which is like this is, you're probably doing it wrong. Switch statements generally are the last refuge of bad design. As you'll notice, what I ended up doing with my implementation is the filter is actually a list of functions which apply the filter. And so if you go down to to-do list, oh my gosh, this is the entire to-do list. So here we go. That is applying the filter. And in fact, oh, I never removed this. Holy camole. Talk about further reducing code size. That was just some debug logging I put in. So this is the entirety of it here. So since I have use filter, which is simple, it just returns the current filter, which is a function. I can just apply it with filter that's built into arrays. Oh, and I don't even want to do this. That's what I want. There we go. I was previously logging all that, but now I'm not. Let's just make sure I did that right. Yes, that should be removed. So the filter is a function. We just filter it, and then we can map the we get a to-do, but we want to create actual virtual DOM stuff out of it. So that's it. That's rendering the entire to-dos. And this could even be much cleaner, except for I'm calling to use to-dos twice within. I no longer need to do that because I clean things up. So, folks, there you go. That's what happens when you simplify it and clean it up. This whole mess, which was the other thing that got eliminated, incidentally, visible to-do list and then to-do list, right? They have this whole extra level to deal with the filtering. This entire file is this line. I rest my case. I'm still trying to learn exactly how Redux Toolkit works. And that's another flaw of Redux Toolkit. In fact, that was one thing that I saw about the people who are sort of supporting me was that they're like, Redux Toolkit is confusing. It should be the opposite. It should simplify things. So it still returns a reducer, which you have to manually add. All right, that's just a little extra work versus this just calls this function called use Redux, and it takes care of adding your reducers to the store automatically for you. It's a little bit of busy work saved, but it also simplifies the interdependencies. Redux React also depends on this up at the top here, this provider, which is just another added interdependency, which I didn't even put in the dependency graph. I didn't think it was entirely fair to put that in the dependency graph, but maybe I should, because it is all of these map reducer things that we saw here, wherever the heck they are. Filter link, I think, was one of them. Yeah, the connect things is doing an implicit connection from React and Redux through that provider, which is just a heck of a lot of complexity when you could just have use filter. Use filter, the implementation of it, which you can come over here and see. So this is the actual implementation. It just says use state, which is a standard hook from Redux, and then it uses use layout effect, which is a standard hook from Redux. And that's it. You don't need this provider at the top. That doesn't give us any additional lift other than additional complexity. So yeah, as I was saying, it simplifies down to just this one-liner. Yeah, it's just like, I don't even know how to describe this. I mean, I look at this and I look at, so it's like that, and then it's this, and then finally you get to to-do. And like, well, this and this, right? Those two together, that's this entire file. And then to-do versus to-do, that's to-do in their implementation. This is to-do in Modular Redux. Again, we're not even using hooks-for-redux, but all hooks-for-redux does is it eliminates this file because it has this implementation in it, so you can reuse it. It's well tested. And then it just becomes like tiny, like nothing. So I'm a little surprised I haven't got more lift out of this article. So I continue to work on this. I've got these 2 new blog posts coming out that's going to talk about this. But today, let's see how much time I got. Like, how much time are we working on here? Evidently, my clock was not running. I'm going to pause and resume, I guess, is how I'll tell. I didn't even really know when I started. All right, so sorry for that glitch. So we're 40 minutes in. We're going to keep going here, but let me do what I really wanted to do today. Look at this. I removed several lines of code. I'm going to have to go update my blog post because I streamlined things. All right. So before I dive into this, I just want to talk a little bit about what Use Redux does. This is the implementation here, which is my Modular Redux concept, but it is exactly the same signature with hooks-for-redux, and it works the same way with hooks-for-redux. So here's what it does. It takes 3 arguments. It takes just a string, which is the name of the slice in the Redux state. So Redux state is just an object. And so this is one of the props. This is the prop name on that object where this particular state is going to be stored. It is the initial value, and then it is this object, which is a list of reducers with a name and a function. And what's significant here is this function takes the current state and the payload in Redux terminology, but you don't have to really think about it that much. It just takes the state and the one parameter. And then you return a new state. Like here, reset to-dos clears the next to-do ID, and then it just returns an empty array. And that's it. So that's how you use hooks-for-redux. And that's it, really. It returns, and then it returns these functions. I guess that's the other thing to do. It returns an array. The first parameter is a function which you can use as a React hook. The second is a list of what I call dispatchers, as opposed to actions, because they don't do the action, they dispatch the action. But I guess it's kind of similar to what hooks-for-redux Redux Toolkit is calling actions. But you invoke it with the second parameter. So each of these has the signature that's almost the same as this, but it has just the second parameter. So add to-do has text, toggle to-do has ID, reset to-dos has no input. And then last, it returns what I call a virtual store, which only gets used in the test here, the testing file. So I'm not going to go into too much. Other than you can see right here, the virtual store is used that you can call get state on it and will return the current state. It looks and acts like a Redux store, but it's only that slice of the Redux store, which is another part of the cool things that you can do with Redux, hooks-for-redux, is you can also subscribe to just a subslice of the Redux store, and in a way that's super convenient. As you can see if you dive into my advanced tutorial. So after I did this intermediate tutorial, that same person said, oh yeah, but that was just the intermediate tutorial. And I didn't actually use the latest React Redux because he or she didn't use hooks. That's fine. So, but you should try the advanced one. So I did the advanced tutorial. Same thing. Just blew it away. Okay. I just have to let me. Okay. We'll just go back to on the gravel. So this is the advanced tutorial. It's a heck of a lot more complicated. It shows the GitHub. It's a GitHub issue browser. And it's a pretty nice little app. It's quite capable. In fact, let's just see. I think if we go here, not here, let's go here. So Code Sandbox, super cool that Code Sandbox does what it does. Basically lets you develop full stack JavaScript in the browser in a way that's pretty nice. I mean, it's pretty decent. And it will run it. So right now it's actually doing an npm install. That's why it's taking a little while here. But there, look at this app, pretty cool. I mean, you got these things. If it's got comments, you can click on it and you can see all the comments. It has these people's names, but if you click on that, it actually just goes to GitHub. It doesn't go. It does not have a routing. That's what they call that. It does not have a router module, so you can't just hit the browser back button to navigate. But it's pretty. You can put in an Oregon repo and load it. You can jump. This is paginated. So, it's legit to call this a pretty complicated thing. These are all asynchronous requests because they're all loading against the GitHub API. RSK, huh? Yeah, so this is the current release version of hooks-for-redux. Does actually use the provider system because I kind of was like, okay, well, I'll try to be really compatible with the existing stuff, but I'm pretty sure this is not needed at all. So that's actually what I wanted to get into today, but I'm probably not going to get to today is hooks-for-redux 2.0. One of the things is it removes the need for provider entirely. There's no reason for it. It just is an added piece of busy work that doesn't get us anything. Anyway, so this is what it is here. You can see what the app looks like. And back to this. So this is their dependency graph, which is insane. Let me just say that again, insane. But it's not quite as insane as that, because as you'll see, my dependency graph is also fairly busy because there's a lot of legit dependencies here, as you'll see. But all of these implicit dependencies with these dash lines, not necessary. I didn't end up simplifying the React components. The light blue components, the purple is Redux specific stuff, a whole lot. And actually not all. I used exactly the same ones. After I cleaned up all their code, they had the right ones. They had good React design. But there's 36 dependencies that are purple, which is to say that are connected to these 6 Redux files. Plus 9 that are implicit. So let's call it 45, which is really more reasonable. 45 dependencies due to Redux. Compared to here, well, there's 20 instead of 45. And this whole box right here disappears if you use hooks-for-redux, because that's what this is, basically. It also reduces the total code size by half. Half. I wonder why that one's not purple. Interesting. But you'll see that almost all of these dependencies are linked to issues display. And the reason is because issues display is what I would call nav state, actually. It's the navigation state of the app. It's what page you're on. It's what you're browsing to. It has several sort of things that have to do with what comment you're currently viewing. It has just sort of this global navigation state of the app. And if you think about it, all of these modules that depend on it legit need access to the display state, the issues display. And then these other ones are actually all pretty reasonable. Comments is only used by the issue details page. Issues is used by the issues list and issues pagination and the issues list page, which is all quite reasonable. And the issues page header shows you the repo deals, and it only is dependent on repo details and the issues display, because I think it also has some of the nav buttons for changing what your display is. If you start looking through this, it's very reasonable. But most significantly, one, it's only 4 instead of 6. And look at the connections between them. There's 3 connections between them. There's an insane amount of connections between them. Further, this uses Redux thunks. Again, I don't understand the justification for it. It's for asynchronous loading. But here's how I implemented asynchronous loading. You can subscribe from these guys to changes in issues display. These guys will load up different things based upon like what if you're for displaying an issue, it's going to load up the comments for that issue. If you change your repo, it's going to load up the issues and the repo deals for that repo. And so these lines are actually subscriptions. They subscribe to changes on this part of the state, and then they update themselves. Let's take a quick look at how that works, because that's something that wasn't shown in the last one. RTK, GitHub issues. I'm just going to go to the Modular Design one, which doesn't have any external dependencies at all, but I suggest you use hooks-for-redux because it means you don't have to even implement the one little bit. But if we go over to issues, so here we go. Mine is organized in the way that I think it's sane. We have components, and the components are organized into pages and partials at the moment. This is sort of a handover that I use from the Rails, Ruby for Rails days that I did when I did Rails. But I kind of like the thing. You've got pages, partials, and widgets. So a widget is something that has no dependency on anything else in your application. It might be specific to your application, but it's like a widget on the screen, like a drop-down, whatever. If the link component that we looked at in the other app really was completely irrelevant, it was just a link, that would be a widget. Most importantly, widgets should not have any dependency on shared state. I don't have any of those widgets in this app, but I would have another folder for widgets. Partials are in between. Partials can be dependent on shared state, and they are something that might be shared on the different pages. So it might be like a login form you might have on the top of the page for each page. That might be in the header, I suppose. But you might have something like that, a little mini form that gets reused all over the place. That would be a partial. And then a page is just a logical page, like you're used to thinking about from a browser point of view. It's a full screen interactive experience that you might swap out for different full screen interactive experiences. And I find that to be a very effective way to organize apps. But it's not, an end all be all, but the point is that pages can depend on partials, partials can depend on widgets, and it gives you a very good way of organizing your dependency structure of your components. But what I wanted to do was I wanted to look at, I wanted to look at the subscription. So let's go down to Redux. So Redux, here's Modular Redux. These two things go away if you use hooks-for-redux. Incidentally, hooks-for-redux has awesome TypeScript for you. For those of you who want to use TypeScript, it actually works really well. When you call use Redux, all of these things it returns are well typed, and so like you can see here, I'm hovering over it. So set repo details is a dispatcher. It takes the state that you want to set. Because that's all it did. You know what? Actually, that's wrong. Hooks-for-redux gets that correct. My apologies, but this is my sort of offhanded single solution here. Yeah, it seems to be. No, this is not quite right, but the hooks-for-redux one is correct. Anyway, what I wanted to go here, so we've got issues display. Issues display specifically has the organization, which is the GitHub organization, the GitHub repo, what page you're on, and what you're displaying, which is display type is again kind of weird. It's actually what page you're on. But it can be issues or comments. And then what's interesting here is let's go to comments. So comments, whenever you change the selected, oh, there's a hidden one here, isn't there? Yeah. Issue display store. I think I took this straight from their code. But there actually should be. Oh, so there is a display by comments. Issue. Okay, so you can't have a selected issue. So that's just a little bit confusing there. I took this definition straight out of their code. I don't really love the way this is from a TypeScript point of view. But the point being is there is a issue field on the state here. Personally, one of the things I'd also consider doing is this nav state is like a merge of a bunch of different bits of state. The organization, the repo, the pagination, and your current page, which is really what your routing should be. These are just a catch-all of a bunch of different states. It's so easy to set up different slices of your Redux state if you're using Modular Redux, hooks-for-redux, that if I was to refactor this up, I actually would have split this up into several, which would make them all much simpler. But right now what we care about is issue. So comments, whenever that issue, the current selected issue changes, then we want to load the right comments for that issue. So here we go. We're pulling in the issue display store from issues. So here is use Redux for modular display. Here we go. So the third part of the array that's returned from use Redux is the virtual store. So this is the issues display store. And comments is pulling that in right here. This is a subscribe method. The subscribe method works a lot nicer than the Redux subscribe method. The Redux subscribe method on the Redux store is kind of weird. So you give it a function to subscribe. It returns a function, which is the unsubscribed function. That's great. I like that interface. But the function that you provide, here's what happens. It gets called every time anything is dispatched, and it gets passed nothing. So much missed opportunities. All right. This subscribe only subscribes to the issues display slice. It gets called only when the issues display slice changes. It changes in a pure functional way. So even if you pass in a object with exactly the same values, it's still going to call this. But that's okay. Most of the time it is going to change in some way that matters. But if it doesn't change, if like some other part of Redux changes, it's not going to get called. And it gets passed the current value for issues display. And I here in this input am just extracting the current value of issue. So if it's null, we're going to clear out the comments with the initial state. I would maybe even consider simplifying that some more. Because we're using TypeScript and TypeScript is cumbersome, I didn't want to go through too much jumping around. I needed a way that I could just clear out the state of everything in a way that TypeScript wouldn't give me a hard time for. So anyway, there you go. It knows the initial state is a comment state object, and therefore it knows it's compatible with this, but it's just an empty object. I would prefer this just to be null. But TypeScript made that really cumbersome to do, so we didn't do it. But here we go. So if it is not null, then we set loading to true so that we can display in the interface that we're loading. This happens so quick that you don't really see it most of the time, but in fact, if you had a slow network connection, we would actually display loading. I'd have to check if I true, but I actually think that because I was able to come up with a consistent way of presenting loading and errors, mine has consistent loading and errors for all the remote requests, but their implementation doesn't because their implementation is so complicated they didn't get to the point of making all those correct. That's why complexity begets complexity, and it's hard to get correct code the more complex it is. But so here, here's my entire asynchronous. I say get comments, which is part of the standard GitHub API, just provided. When we do this wrapper, I just use this they provided. And so maybe get comments was implemented over in that file. It's another file in this project. But anyways, it's the same file that they used in their the Redux Toolkit implementation. So we provide a URL, it says get comments, it retries a promise. The promise resolves to either comments or reject with error. And I could almost split that out, but this was easy enough. So one way you can do promises. Often you do just .then and then you have your resolver, and then you do .catch and you have your error catcher. But this is a lesser used formula, but you can actually just provide the resolve path and the reject path, pass them both to then. So we take the comment and we say set comments, we pass in the comment. We take error, we say set errors, and we pass in the error. That's it. It's hard to say a lot more than that because this is all of the asynchronous code in the entire app for comments. Just right here. We load them, and because of the way I structured it, like notice that both of these things sets comments, which is setting the entire comment state, which clears out loading, makes loading empty, and makes error loading. So it resets error, resets loading by doing this. Similar with this resets loading and it clears out comments. So if we had previously loaded comments, it clears them out and it shows the error. That's it. To be unfair, or to be fair, let's take a quick look. Is this it? Yeah. So this is theirs implementation. So I can't even find this easily because it's not organized in this way. So we are looking for, clear this one out. And this one. We're looking for comments. I think they called it comment slice. So maybe I can just find it. Comment slice. All right, so yeah. All right, so this is doing more or less the same thing, right? All right, first of all, why are they dispatching? You should not ever manually dispatch anything. Manual dispatch is part of the problem, not part of the solution. So you compare that to this. I also don't know. Does this work if there's no issue? Like if issue is null? Like it's going to crash right here. So I wonder if I even need this. Maybe issue never gets set to null. I'm not quite sure how they're handling that, honestly. And look, they're there are no words. All right, so they're doing manual dispatch. Oh, that's what's weird about this, right? So get comment start. All right, so the signature for this is nice, sort of. Yeah, the signature just passes in the payload, as it should, but it returns an action. It doesn't actually do the dispatching. Is that really right? I can't even dive into too much. This is all part of why I don't. Redux Toolkit just sort of blows my mind a little bit. It's like, what the heck is it doing? Why isn't this just doing the dispatch? Anyway, they get away with a little bit here because they're using an await, but short of await, you have to. Await is an unfortunate JavaScript construct because there's no reason you have to declare async over here. Like if you're using await, it is automatically async. It cannot be anything but. So this you have to also declare async. But they kind of get away with a little bit simpler because they don't have to have a .then. But you can see for all the complication that then did for us. I could have done the same thing, but I don't like the fact that await has to have async. I agree. Await can be very nice if you're doing a lot of .thens. But in this case, it doesn't actually give them all that much. So we .then, and then we've got our two things here. Because it's going to throw an error, which then they have to catch, right? So await got them nothing here. It just is it's more complicated than this. So, you tell me what you think. My main problem is you look at this and you're like, oh, if you don't know about thunks, then you're like, what the heck is going on here? Because there's no direct dependency on thunks here. So I'm going to go do this because I think that this is important. I think this needs to be accounted for. We're going to do this and this. Send that to back. Comment slash issue slice. And repo details slice. Better go just check all these guys. But and just go to the back, please. You know, I'm not just trying to be mean here. I'm really not. I want people to write good code. I want to be friends with the Redux people. I'm not trying to be overcritical if you guys Redux people end up watching this. I mean, I am being kind of critical, but you got to look at this, and it's not good. It's just not good. And recommending this to people is perpetuating bad design for people and making people have a real pain and a headache. All of those are totally dependent on Redux thunks because look, it's freaking using thunks. It's getting passed through the apps, the store. That's the direct dependency, but it's the thunk pattern here. Like you have to, if you decided not to use Redux thunks, all these files would have to change, which is say they are all dependent on Redux thunks. And for reasons which baffle the mind, honestly. I was not able to get any good answer about why you would use that. Yes, that uses app thunk. In fact, let's just see who uses app thunk. Store uses comment slice, issue slice, repo details slice. So yes, 12 dependencies, which brings us up to 48 dependencies compared to 20. So that versus that. All right. And why in the heck is that not purple? So this is one of the things that's kind of cool about OmniGraffle. It is style. I can copy object style, and then I can go over here, and I can say paste object style. Pretty. All right, well, I think we're probably coming up on time, honestly. So I didn't get into making Redux 2.0. Hook-for-redux 2.0 is mostly done. But the one thing I wanted to add was this way to incrementally convert an existing app from normal Redux to Redux, a hooks-for-redux. And it's actually a very little addition I need to make, which basically allows you can pass in your own reducers like normal to create your store. And so you can just use everything you're already doing normally with Redux, and it will just work. You plug in hooks-for-redux using hooks-for-redux's create store, because it needs a slightly special store. And then you can incrementally change one slice at a time over to the new hooks-for-redux. And so I wanted to implement that a little bit, because right now you cannot pass in your own reducer. Hooks-for-redux wants to manage all the reducers, which is, actually not a great design. It was my first implementation. I did want to, as we wrap up here, just go look a little bit at the implementation of hooks-for-redux. So let's do that, and then we'll have some final thoughts and some questions for you to think about and give me feedback. So hooks-for-redux consists of these files. One of the things hooks-for-redux does is it creates this little thing called the store registry, which is basically purely optional. Most apps up to a certain size, maybe even to a large size, only need one Redux store. So why do we go through all this effort of manually creating it and manually collecting all the reducers into it, when that could just be done for us automatically? And that's what this does. If you call get store, it's going to vivify a store. It's just going to create a store for you. And if you call set store, it will replace that store with a new store. So if you want to do a custom Redux store, great. you can call setStore first before getStore gets called. And getStore gets called from useRedux if you don't provide your own store. But you can avoid this entirely. You can just create your store and then pass it to each of your Redux slices and specify it explicitly when you call useRedux. And that's if you decide you need multiple stores, that's a great way to do it. And if you need, the whole point of that sort of provider thing is that you can maybe have different parts of your app have different stores. And that uses the React context concept. But I don't like that. It creates, again, implicit dependencies. If I've got some component which expects some parent somewhere up the tree to have the right context so it can do its get and fetch its state, what if that parent moves away, gets swapped out with a different parent? What if I take that component and try to reuse it in some other place in the tree that isn't directly underneath that parent? It's just going to break, and it's going to break for unclear reasons because there's no direct dependency. It's an indirect dependency. You can do the same thing with this. You can create an explicit store for some subpart of your tree. If you wanted to isolate the store into like a reusable, maybe you make this whole reusable React component with Redux store that you want to share with other people in the world, and you don't want to conflict with their Redux, whatever they're doing. Great. You just create your own store and you pass it to each of your own useRedux calls, and you're done. That'll do it. And you don't have to have this provider thing. And if your components change their structure with respect to each other, it'll all still just work. It's all direct dependencies, not indirect dependencies. So that's Redux Store. Provider, again, is getting deprecated. All provider did is it's just the same provider that React Redux uses, but I just automatically set the store to the default store for you. You can override it if you want to. But I've come to the realization I don't need to use React Redux at all. It's a 3-line piece of code. Reason why I needed to use this was because I wanted their hook for React, but I can replace that hook with 3 lines of code. So I did. The virtual store. So here's what hooks-for-redux needs. It needs a slightly different store. It needs a store that is updatable. Virtual store is not the right one to look at. Create store. And it's creatable. I made this function called the inject reducer function, which is what Redux officially recommends. They have a whole page about this, which I have links to from the doc, which recommends how to inject reducers. And all it does is call replace reducer, which is a standard function on the store. I'm just, sorry, just getting a little distracted here in my brain. It's all good. So anyways, basically it's just a standard Redux store, except for you can call inject reducer. And what I want to add is actually right here. That's this hooks for Redux 2 is going to, right now it takes in a map of reducers, which is not the standard signature for Redux. Instead, I'm going to also allow you to pass in just a function, which would be a reducer. And that reducer will just stick around, which is nice because normally if you say replace reducer, it'll just replace everything. But here we just want to, whenever we call inject reducer, it just adds another reducer. And so that's what that little change will support, which allows you to incrementally add this in or combine it with other ways of using Redux. I wouldn't probably recommend that, but maybe there's an example where that makes legit sense. And it always makes legit sense if you're migrating from one solution to another and you don't want to make all the changes at once. Migration, if you can make incremental changes, converting from one to another, and that's a clear path of incremental changes, you're going to have a lot less pain than trying to change everything all at once and hope it works. So those are the little ones. Virtual store we talked a little bit about, which is it has these 2 methods, which are standard methods on a Redux store, but they just work on the subslice of a Redux store. Get state gets that state, and then subscribe works as I described in that special way that it only calls your function f if the state has changed, and it just does a strict JavaScript equality test. So it'll call your function too often, but that's okay. It doesn't care if it's a little bit too often, because most of the time it'll only do it if it changed, even if it didn't change its values, it still got updated in some way. So that's a perfectly reasonable test. And then it calls it, and it automatically passes in the current state, which for some reason in the Redux implementation, it doesn't. Like every time you get your subscriber gets called, it gets called past nothing, and you're always going to go call get state, which means that your subscriber has to also be dependent on the Redux store because it has to go out to the store to get the state. So it's like another aspect of poor modular design, and that's in the core Redux implementation. There are a few things I would complain about the core Redux implementation, and that's one of them. The subscriber should give you the current state as part of the subscription. The other one is there's no official documentation for middleware, which is weird. But I went and looked at all the doc, and there's no documentation on middleware, and it's not immediately obvious how middleware works. Middleware should be really simple. There's not a lot of complexity what middleware needs to do. But I don't know. I'm reserving judgment because I don't understand how the middleware works. But I like middleware for Redux. It just seems like it could be done a little simpler. But I'm reserving judgment there. Anyways, let's dive into the main implementation. This is everything. This is all the real functionality of hooks-for-redux, and it's 32 lines of code, which is why I was able to reduce the Redux Toolkit implementations by half the code, even though I didn't use any external dependencies, because this is all it takes. It takes this much code to implement the modular implementation. In fact, this right here is kind of redundant. This is the use Redux has a simple signature and where you pass in no reducers, and it has a signature where you pass in reducers. So this is kind of, if you're using reducers, you'll never use this. It basically provides a replace all reducer by default and a set reducer. But here, use Redux. You pass in the store key, which is the key for parameter for the property where it's going to get put in the store, the initial state, and your reducers. It's funny that they call them all NEs. There is right up here all the TypeScriptiness, all the TypeScripty goodness, including all of the nice little Java doc stuff, JavaScript docs. So when you use it, it works super well with TypeScript. So you pass in a set of reducers, and you can pass in a Redux store, or it'll automatically just call get store if you don't pass one in. So you didn't see previous examples where we passed in the store, but that's how you would do it. You just pass it in as the fourth parameter. No problem. So first of all, it says inject reducer, and it just adds our reducers. Oh my gosh. And so here's what the reducer does. This is the entirety of the reducer. Notice there's no switch statement, because again, the recommendation that you use a switch statement was just boneheaded to start with. If you're using switch for dispatch, I learned this when I learned C++, and I learned this when I learned object-oriented programming. If you're using switch for dispatch, you're doing it wrong. Languages have things built into them which do dispatch, particularly if you're using a language that's OO, but even if you're using a functional language, it can do it. Pure functional language. I don't know what pure functional. A pure functional non-OO. Functional and OO are not, they're tangential. I hate the fact that people talk about OO versus functional. They are complementary, not conflictory technologies. But nonetheless, if you're working with a functional language that has no OO support, you can still do dispatch without a switch statement. In fact, yeah. Anyway, you should never use switch statements for dispatch, because here's why. So here's my actual dispatch function. It takes the current state, and it takes an action, right? That's how you do a reducer. Their action has a type and a payload. Here's our reducers, which is an object. We just see if in that object there is a type. There is a reducer for that type. If so, we apply it with the state and the payload. Otherwise, we just return the state that was passed in. That's it. It could be an enormous amount of reducers, and it would still be a single object lookup, object invocation, object method invocation. So easy, and also so clean. It does not need to be a long switch statement. But now we basically added our reducers to the store, which says that they'll get reduced through. The other thing I've been considering adding to hooks-for-redux is namespacing the type. The type currently is just the name of the reducer you pass in, and that could easily conflict with other reducers in ways that would be confusing. So I've been considering namespacing it by combining the store key with the type. But it makes this really elegant implementation significantly more convoluted. Because right here, I can just use reducers directly with the type. I just pass it in, I read it up, read it out. It's elegant. Same thing with dispatch. I just dispatch the type right here. I still might do it because I think it's probably a good design and it doesn't add too much complexity. And then that's it. And then we're almost done. Then we return the three things. We return use selector, which is from Redux React. Let's switch over to the new one. cd hooks get checkout. Two. Yep. This is my shell here is fish, and I'm also have a special additional plugin that shows me these cool prompts. So this shows me what branch I'm on. How cool is that? But when I said get checkout and press tab, fish knows that I'm doing get checkout, and so it shows me my branches available and gives me this nice little browser GUI so I can just browse through and pick the branch that I want. Highly recommended. If you want to know how to do this funky thing here, I'll have to look it up. You'll have to ask me in the comments. Definitely do ask me. I can look it up for you and tell you how to do this cool prompt. All right, so this is removing the dependency on React Redux entirely. So we're just going to do our own hook. And I pulled it out here separate because I decided I actually wanted to name each of these so that if you, at least the functions, if you would look at this function and say, what is your name? It'll at least say use slice rather than anonymous. So you have some clue about what it is. So use slice, takes in nothing, and this is the entire implementation. It uses use state, uses use layout effect. You might actually notice that this looks identical to we very briefly looked at it in the Modular Redux a moment ago. Same exact implementation. In fact, that's how I came up with this. So I implemented it, tested it with the Modular Redux, and just moved it right over here. Super easy. I found it a little convoluted that I had to use two different hooks in order to make this work, but it's what I had to end up doing. That was the best solution I come up with React hooks. I like use state. I think use state is great, but some of the other hooks seem just a tad clunky. And there seems to be too many of them, more than you really need. But basically, this one, this is where we actually subscribe. We use the virtual stores subscribe method, which we talked about the virtual store a moment ago. So it'll subscribe to state changes. What's cool about use layout effect is that the return result of this function is treated like an unsubscribe. And so when the component gets unmounted, it will call the return function that gets returned from this, which is conveniently the unsubscribe to unsubscribe it from the virtual store. So that's kind of cool. We get that all for free because the subscribe method is awesome. That's what makes this particularly elegant. The unsubscribe is just built into this right here. It unsubscribes at the right time automatically for us. I had to add this little thing. Says this is dependent on this, which means that it won't rerun this because it was subscribing multiple times before. And this says only rerun this when this changes. Well, use state guarantees that this will never change. So it'll only run this once. Really? There's not a better way to do that, React? Okay, fine. I accept. And then I actually wanted to have the state get passed through. So this also only gets run once. Because I made it a function. Because the way I use state works. So it only calls this once. It gets this state initially, but then afterwards it calls set state. So we subscribe to V. Oh yeah, this is the other little convoluted sort of clunky thing, is that I didn't actually need to do this. But if your state is a function, use state and I think subscribe would be fine. Yes, calling set state or use state If you call it with the function, it invokes that function and it sets the return value as your state. But if you want your state to be a function itself, this is the only way to do it. So this little extra functional notation here has to do with supporting Redux states which are functions, which is what my filter for the to-dos was doing, if you recall. In general, I don't always recommend that solution because I think that's best. Redux is at its best when your state can be serialized to a JSON object. And incidentally, that would not have made my solution much more complicated than the to-dos, but it would make it slightly more complicated. But just in case you happen to be using function as your state, I didn't want to have it break. So I put that little additional bit of code here to make that work. So this is arguably one of the more complicated functions. It's just 3 lines. Really, it's only 2 lines. But now you kind of see what it's doing there. And then we generate our dispatchers, which is our second return value. Dispatchers is just we take each of the reducers and we take the name of each reducer here, which is the type, and we assign it to our dispatchers, which is a map here. And it takes a payload as an input and it dispatches its type and its payload using the store. That's it. That's how you do the dispatchers. And then the virtual store, we're actually calling create virtual store, which is coming from over here, but you can see how big the virtual store is. I only have it in a separate file just for clarity because it's conceptually something that's separate. And that's it. That's how use Redux works. It's really not complicated. It does turn things on its head in that it says your slice of Redux should register itself with the store by default, unless you want to specify the store, in which case you can pass the store in, rather than the other way around, which is what Redux Toolkit still makes you do, which is it returns the reducers and you still got to manually plug it into your store. I think that's really backwards. The fact that you're doing reducers, the fact that you're doing dispatch, that is an artifact of the way Redux works to achieve its primary benefit, which is serializable global states. You can persist it and restore it to put your application in any predictable state for testing and just for interactive testing and automated testing. And you can serialize a sequence of dispatches if they are, again, JSON serializable and replay them. And you can even replay them like in real time. So they would do exactly the same sequence in the same time, which is, again, great for testing or even for demoing your app. Like you could actually have like a demo mode for your app that just walk through and demo everything, which is very cool features. And the updates are pure functional because you're actually mutating state, but they're pure functional in the sense that they are transactional. They are atomic and transactional. So they take one state, generate an entirely new state based upon that previous state. They call those reducers. But what's important is that it is an atomic transitional update. The fact that it has a dispatch is nice from the point of view of your debugging tools, but it's not really a great programming paradigm from the point of view of modular design and minimizing dependencies so you can maximize refactorability, editability, understandability, and minimize complexity. So I'm going to stop here. This ended up going a little bit long. I always like to end it with a question. So questions to you. I didn't really dive too much into why you would use Redux at all, although I did kind of say the benefits. Because a lot of people are like, oh, you should just use React hooks. And in fact, you can use React hooks combined with the React context to implement shared state. But you're using the React context again, which, as I explained previously, I think that's problematic. I don't actually think React context is a good idea. It seems like a good idea at first, but because it locks you into a relationship between an indirect relationship between parent and children, which will break if that relationship gets broken, and it's not explicit, so it's not clear it will break if you change that relationship. I don't think it's a great answer. Versus Redux does a great job if you use it in this modular way. So, questions. I'm going to leave you with this sort of thought here. So, one question I'd like to do, that sort of question is a little bit too, I'm going to pose this question. I don't expect to get an answer for it, but why is Redux written the way it's written? My theory is that comes from people who have a functional programming background, and they think about problems in a certain sort of functional way. Like having something that registers itself is not functional, right? Because I'm mutating something to have it register itself. But in and of itself, Redux is actually not pure functional. You're mutating state. You just have well-defined state mutations. And that's sort of, I like having code be very close to pure functional. I think that's good. But no code is pure functional. Even pure functional programming languages are not pure functional. They have mutable state. State changes over time. If a state did not change over time, then the application would have it would be dead. Like nothing would happen. It has to have mutatable state. What matters is that you update state in a predictable, well-defined fashion. And you isolate where state can change to a very small chunk of your code that's well-defined. And that's what Redux does beautifully. I don't see any reason not to have a register slice way of solving things, which simplifies stuff. My measure is always what is going to be simplest. And because complexity is what kills productivity. And statefulness is a big complexity thing. So you need to be wary of where you add it. So I can understand not having a register yourself system, right? Okay, that only saves a little bit of complexity. But the big thing is this obsession with using the dispatch system everywhere and exposing the dispatch system everywhere. I don't understand that. Dispatching is clunky and it should not be done manually. It's clunky to do it manually. So if anyone has any insights into like a benefit for exposing the dispatching system more, I'd love to hear it, but I've seen a lot of examples, and every time I see an example, I'm like, yeah, but that would have been simpler if you hadn't exposed the dispatcher. And but I'm happy to take examples and dive into them and play around with them and see how we can simplify it. I am curious, because my broadest question is, I think good software engineering is mostly about managing complexity. Perhaps it's entirely what it's about. And for me, more and more, I find it comes down to a few things. I think modular design is critical. It's one of the biggest things. You need to be able to chunk your code into small parts that you can reason about fully, that are fully isolated and watertight as much as possible, and expose a very minimal clear API to the other components so that you make that one component easily testable in unit testing and easily reusable and well-defined. And if it has that hard split between the outside world and the inside world, you can change all the internals without breaking the dependent objects. That's why it's a bad design to have all of this React code dependent on Redux. If you want to solve out Redux, I think I alluded to this before, the advanced tutorial for React Redux is so crazily intertwined. That's that. For the intermediate tutorial, I did go through each of these files and I slowly converted them one at a time. I couldn't even do that. This is so crazy that in order to convert that into this, I just had to throw them out. I couldn't reuse a single line of code. I had to refactor everything because it's bad modularity. Ultimately, for project, refactorability is the ultimate measure, right? How easy is it to adapt the code to new requirements? And but mostly, what makes code more refactorable is if you manage its complexity, if you make it strong modularity, if you minimize the interdependency between modules. That's really, I think if you minimize each module, you'll end up with minimized dependencies most of the time. But maybe I just do that intuitively. I'm not quite sure. But for me, if I focus on each module, make sure it has as few external it is dependent on as few things as possible, and its API is as focused as possible. You'll have to see my modular design article, which I'm about to release, because it really goes into this in good detail about how you design individual modules to be good and modular. I think you'll end up with a system which overall has minimum interdependencies, 13 versus 27. And really, if you have hooks for Redux, it's 12. So what I want to know is, from a software engineering point of view, are there exceptions to that rule? Is there exceptions to minimizing each module and minimizing the overall modular interdependencies? Further, so that's from the modular perspective. I would add dry is almost all software engineering comes down to dry. And I could argue that you could define all this modular redundancy as a failure of dry, but that's a little convoluted. I might be forcing a little bit, but most bad code I've ever seen comes from repetition, repeating the same pattern over and over again, whether that is actual copy and pasting code, which is the worst. But in this example over here, you go look through that code and you were using the same pattern over and over again, same bad pattern, and creating too many replications of things. Like, for example, these implicit dependencies, right? This comes from filter link pulls over information from filter slice, but then it does very little with it, if anything at all, and passes it off to link. Well, that is, let's go look at it real quick, because I think that's the only way I'm going to be able to explain that. It is a code, RTK, convert ToDo's. I actually just want their version. The problem is, so filter link depends on the filter slice, and it wants set visible filter. So it brings in set visible filter. Well, all right, I got one. Consider this string part of dry. So I've got 2 copies of it here, and then it gets passed over to link, 3, 4, 5. 5 repetitions of it. Now, RTK demo modular design. This is just in the component end of things. But if I look at the component end of things, and if I go to, it's now entirely in footer, right? So theirs was set visibility filter. And mine was, oh my gosh, I have too many things open over here, which is just set filter. So I have 2 copies to their 5. That is a dry failing. And when you start to try to dry that up, all of a sudden it forces you down the path of good modular design just by using dry. So that's why I say almost all good software engineering comes down to dry. But I think it's useful understanding the modular design pattern, because that is also a way to apply dry, but it is a way that is conceptually, you really need to understand the concept of modular design to really get the most out of it. And then at the end of the day, so we have modular design, super important. Dry, I think, includes, you could argue dry is a superset of that. And the ironic thing is that I think the superset of all that is just writing less code. You've heard me say it before in this, I was about to call this a podcast, but this live code. It's writing less code. It seems so dumb. Like, oh my God, as a developer, of course you should write as little code as possible to deliver value. But as I say that, I'm not sure that's so true. I'm not sure a lot of people think that way. I do wonder how many people do it from a job security standpoint. I imagine a few people do. The cynical part of me thinks that there's probably a few people out there that do it. But I think most people just don't realize that taking the extra effort to write a little less code, it takes more effort, at least to learn the patterns. Once you learn the patterns, it becomes really fluid, becomes dramatic. You can have half the code size to do the same amount of work, a third the dependencies. And that's how you write big applications that scale, that are robust. If you don't make minimizing complexity, minimizing code size your number one priority, that's the path to the dark side. And I've been preaching this gospel for a while, and I expect someone to chime in and say yes. But let me know. Let me know what you think. Are there exceptions to those rules? That's really what I want to know, because I want to learn. If there are exceptions that I haven't considered, or scenarios that I just haven't been in, places where it makes sense to really break these rules in a big way. I will say the exception with write less code is that you should never, there is code obfuscation where you can write so little code that it's completely unclear what it's doing. You should never write less code that makes it confusing what's going on. But I think that it is reasonable to assume that people understand the language that you're using fully. So you should use all the language capabilities fully. As long as it's clear, given that you assume someone understands the language's capabilities, I think you should write as little code as possible. And I think that all the rest of this falls out from it. Not that these aren't useful concepts in and of themselves, because they are tools that help you know how to write less code. But when it comes down to it, it's less code. Code size is the ultimate simple metric. And I think I've said it before on this. You can measure lines, it's okay. But I recommend measuring tokens. Tokens is the minimum semantic atom of a piece of code. And if you measure tokens, then you conversely don't artificially constrain people to write terse variable names, terse function names, because that's all just a token rather than it's short or it's long. And in fact, it'll encourage you to write long ones because you can write smaller code that's still clear because you have descriptive function names, descriptive variable names, which all just leads to really good. So I'm going to stop now. Thank you for staying with me past an hour. My name is Shane Brinkman-Davis. I work with GenUI, and we are a software consulting company. And so I see a lot of bad patterns at other places and good patterns too, and try to help guide people down the path of sustainable code. And my own company is AmyKimmy, which amykimmy.com is our website. And so I've done a pretty big app based on these projects for my own stuff, and it works great. And one person can manage it. And yeah, thank you so much for sticking around. And I'm looking forward to doing these more regular in 2020.